At the core of every computer lies a marvel of modern engineering, the processor, often referred to as the Central Processing Unit, or CPU. This small but mighty chip serves as the brain of your computer, responsible for executing the instructions that power everything from simple calculations to complex software. Without a processor, your computer would be nothing more than an inert collection of circuits and wires. The processor's role is to fetch, decode, and execute instructions stored in the computer's memory. These instructions, written in a language the processor understands, dictate every task the computer performs. From the moment you press the power button to the time you shut it down, the processor tirelessly carries out its duties, acting as the driving force behind your digital experience. The speed and efficiency with which a processor can execute instructions directly impact the overall performance of your computer. A faster processor translates to faster application loading times, smoother multitasking, and a more responsive computing experience. Therefore, understanding the architecture of a processor, its components, and how they work together is crucial for anyone seeking to comprehend the inner workings of their computer. A processor is not a monolithic entity, but rather a complex assembly of interconnected units working in harmony. Among the most critical components are the Arithmetic Logic Unit, or ALU, the Control Unit, or CU, cache memory, and registers. The ALU, as its name suggests, is responsible for performing arithmetic and logical operations. Whether adding numbers, comparing values, or performing bitwise operations, the ALU is the workhorse for all mathematical and logical computations within the processor. The control unit acts as the conductor of this complex orchestra, fetching instructions from memory, decoding their meaning, and directing the other components to execute them in the correct sequence. It ensures that data flows smoothly between the processor's various units, and that instructions are executed in a timely and orderly fashion. Cache memory is a small but extremely fast type of memory located directly on the processor chip. It stores frequently accessed data and instructions, allowing the processor to retrieve them much faster than from the main memory or RAM. This proximity to the processor significantly speeds up processing time, as accessing data from cache is considerably quicker than fetching it from the relatively slower RAM. Finally, registers are small temporary storage locations within the processor itself. They hold data that is actively being processed by the ALU or used by the CU. Registers are the fastest type of memory available to the processor, and their efficient use is crucial for optimal performance. The coordinated operation of these components forms the heart of the processor's instruction cycle: fetch, decode, execute. It begins with the CU fetching the next instruction from memory. This instruction, encoded as a series of bits, is then decoded by the CU, which determines the operation to be performed and the data involved. Once decoded, the CU directs the necessary data from memory or registers to the ALU for processing. The ALU performs the specified arithmetic or logical operation, and the result is stored back into a register or memory location as instructed by the CU. This cycle repeats continuously, with the processor executing millions or even billions of instructions per second. The efficiency of this cycle is paramount to overall processor performance. Factors such as clock speed, which dictates how many cycles the processor can execute per second, and the number of cores, which allows for parallel processing of multiple instructions, significantly impact the processor's speed and efficiency.